Hello everyone, my name is Permal Jagan and we are doing the static analysis of uh, malware. So we are actually in the middle of solving TryHackMe walkthrough room, and I'm going to continue this part. I'm going to continue the same thing in this part. So it's going to be part two. So without further ado, let me start sharing my screen. Okay, so we have solved around four tasks before. Now this one is the second task, the second part. So in this we are going to learn some signature based detection. So let's learn this. Mm, in the previous task, actually, we learned about the file hashing and the string identification, string deobfuscation by using flaws. So we have learned all those things. But now we are going to learn about the signatures. So how the signature is going to help us to identify a malware. So that's what we are going to learn. So let's see. Signatures are a way to identify if a particular file has a particular type of content. We can consider a signature as a pattern that might be found inside a file. This pattern is often a sequence of bytes in a file with or without any context regarding where it is found. Security researchers often use signatures to identify a pattern in a file, identify if it is a malicious or if it possesses any suspicious behavior. So it is all about picking a particular pattern from a file and trying to match that pattern with the existing signatures that is loaded on a security control or a machine or an endpoint. So that is the concept of matching the signatures. Then the next one is the YARA rule. YARA rules are quite important in malware detection because these are the familiar uh, rules. I mean, the YARA rule is quite familiar in the malware fraternity, malware analyst fraternity. YARA rules are type of signature rules based on, it is famously called a pattern matching Swiss Army knife for malware researchers. YARA can identify information based on binary and textual patterns such as hexadecimal and strings contained within the file. TryHackMe they actually offer a dedicated room for this, but I guess it is good to uh, continue this one. Maybe later in another stream we can do this YARA stuff. The security community publishes a repository of open source. So here is an open source YARA rules repository. I guess it is holding some predefined YARA rules that you can you can grab those YARA rules and deploy in your security solution. All right. Proprietary signatures. Besides the open source signature, antivirus companies spend a lot of resources to create proprietary signatures. The advantage of this proprietary signature is since they have to sold commercially, there are lesser chances for false positives. These YARA signatures and all are open source stuff, but when you go with an antivirus purchase, they will be offering you a set of signatures. In fact, they will be providing you a periodic signature update, so it will be little more promising rather than using than the open source signatures. AV scanning helps identify if a file is malicious with high confidence. Antivirus software will often mention the signature that the file has hit, which might hint at a file's functionality. However, we must note that despite their best effort, every AV product in the market has some FPs and some FNs, false positives and false negatives, I guess. Therefore, when analyzing malware, it is prudent to get a verdict from multiple products. VirusTotal website makes this task easier for us. So let me open VirusTotal as well. As you are all beginners, I mean, I'm just considering it. The stream is for a beginner perspective. So here is the VirusTotal tool. If you search for any particular file in this VirusTotal, you will be able to see the set of security vendors and their verdict, like whether they flagged the particular file as a normal one or malicious one. So you will be getting the result in this single platform. So that's the beauty of this virus total. And please remember, if you are analyzing a sensitive file, it is best practice to search for its hash on VirusTotal and other scanning websites instead of uploading the file itself. Yes, so when you are doing the malware analysis on a secret or your client environment, you need to maintain some privacy, some best practices, some you need to avoid the leaking the information from your client environment. So in that case, what you can do, you can just take the hash of a particular file and you can try to do some hash based search on the internet, because if the file is already exist on the internet, you will see the results. That's what they mean. Okay, now let's move on. I'll tell you about another tool called Kappa. Kappa is another open source tool created by Mandiant. The tool helps identify the capabilities found inside a PE file. Kappa reads files and tries to identify the behavior of the file based on signatures such as imports, strings, mutexes, and other artifacts present in the file. I'll tell you what is the import and mutex in the upcoming session, but if you, I mean, we already read what is the strings, the term strings in a binary. For further detail in the background of Kappa, we can visit the GitHub page or the blog post. All right. Now, if you just open a directory where you find your malware, you can simply use Kappa followed by the malware name. It's gonna bring the list of capabilities to identify the capabilities of a binary. It's gonna predict the capabilities of the binary. So let's use it against a sample. Here they have used, actually they have used it against a sample called 1, right? So why don't we do the same? We are already in the page and I'm simply calling Kappa and calling the binary name against it. Now it's gonna find, or it's gonna predict the behavior of the malware, and it is taking some time because it is scanning the whole executable file to predict the behavior. Let's wait for a while. You can see how long it takes. Gosh. So once the analysis is done, it's gonna give you the result. We will wait for the result. So the result will look like this. See, it actually dumps the hash value from the MyTray framework. It actually lists the tactics and also the techniques: defense evasion, discovery, execution, and there are some techniques as well beneath every tactic. And MBC objective, I'm not sure what is MBC, the term, but anti-static analysis, cryptography, I think some anti-analysis features present in the binary. Anti-static analysis, cryptography, file system. Okay, and the capability, if you see, it has some obfuscated string, encrypt data using RC4, the encryption scheme. It has the PDB path. PDB is actually, I think, let's see what it is. PDB in malware analysis. Program database. Crucial because fully contain the debugging symbols embedded in the executable. Okay, so the file actually stores the debugging symbols and contains the resource section, accepting the command line argument or not, console, delete file, read file, write file, host name. It actually enumerates the host name, looks like, enumerates the GUI resources. Yeah, so these are all the capabilities possessed by the binary. That's what they meant. And looks like it is still running. Oh, come on. The MBC, here is the expansion. Malware behavior catalog. If I open this, anti-behavioral analysis, anti-static analysis, execution. Okay, so here are the mitrate tactic, and under a tactic, I think there will be a lot of techniques. So this is what they call as MBC. Yes, malware behavioral catalog. All right, awesome. So let's see. As we might see, it also tells us if there are obfuscated strings in the sample, allowing us to identify if running flaws against the sample might be helpful. To find out more information about sample, we can use -v or VB operator for the verbosity. So let's now use kappa against file 4 and answer the following questions. Okay, I think I will just abort this against 4. So let me run against 4. Is it going to take more time? I'm not positive. Let's wait. How many matches of the anti-VM execution techniques were identified in the sample? So I need to wait for it to finish before answering these questions. So till now, we have never executed this file. We are using certain tools trying to assess the files or trying to predict the file's behavior just without executing it. So these details could not be always true or need not to be true always. This is just a prediction. So it might go wrong. Okay. But it will give you an insight. So that's quite important before you start doing or stepping into advanced analysis part. But I don't know what I'm up against. Come on. It's taking a lot of time. Kappa. Can I see kappa? Or kappa.exe. Is there a file? Yes, kappa.exe is detected, and I'm trying it against 4, the sample. Now it is also analyzing. So I am analyzing the sample in different windows. I guess doing it from the command prompt works. Some issue. It is not giving us the results. Let's wait, and you can see it's happening. I think next one can be solved by using the PE Studio. But for now, I'm using kappa. Come on, it's taking longer than expected. Oh my god, it's stuck. Can I move to the next one? So I let this to finish, but before that, let's go and solve the remaining things. Leveraging the PE header. So you need to know what is PE. PE is actually the format called portable executable. In Windows, every executable file is actually based on this PE header. I mean the PE, the portable executable format. So that's the PE header is all about. So let's see what it is. The program that we run generally stored in the executable file format. These files are portable because they can be taken to any system with the same operating system and dependencies. They will perform the same task on that system. Therefore, these files are called portable executable files. The same file, accessible, executable across the same operating systems. It hung, looks like it hung. The PE file consists of sequence of bits stored in the disk. The sequence is specific format. The initial bits define the characteristics of PE files. The initial part of PE file is called PE header. Several tools in the Flare VM can help us to analyze the PE header. PE Studio is one of them. We already familiarize ourselves with PE. Okay, we are going to use PE Studio to assess the PE headers. And there is a separate room on TryHackMe that talks about these PE headers alone. And you can see every PE header and what is the purpose of each header. Linked libraries, imports, and functions. Oh, come on. It's still hung. All right. Now we got the response. So we can start answering the questions. But before that, let's finish it. Linked libraries, imports, and functions. A PE file does not contain all of its code to perform all the tasks. It often reuses code from libraries, often previously provided by Microsoft. So the functions from these libraries are imported by a PE file. So basically, an executable file pulls or grabs or imports some of the functionalities from other files. So sometimes from a DLL file, sometimes from other executable file. I think that's what they meant here. If you see in the PE header, when you click library, you will see the list of libraries. So all these libraries provide some functionalities to our executable. Okay, that's what this library section, and the function option is just below, shows the functions imported from these libraries. So every library given here will hold bunch of functions. So out of all those functions, this binary might require very few functions or one or two. So this particular functions tab list all the functions that are imported and also its respective library. And you can see the blacklisted functions here, and that's the importance, or that's the advantage of using PE Studio. It's gonna highlight some suspicious or blacklisted function details. So these are the function details typically used in a malware. So that's why they highlighted it. Identifying packed executables, as we have seen. So okay, packaging is actually a different topic altogether. To obfuscate or to hide the whole executable code, the malware authors often try to pack or bundle the malware by using a tool, a packager they call, and they package it and they try to distribute the malware to the systems, to their victims. So when they try to access the file, they won't be able to understand anything because the file is packed. So while packing, it won't alter its behavior, the behavior of the malware. However, it will simply try to obfuscate, try to hide the actual functionality or the actual source code of the executable. I think that's the gist of using packing. Okay, so that's what I think, that's what they tried explaining through this paragraph. The dissecting PE headers is a room that I think I will be doing it maybe in our upcoming videos or streams. But for now, let's try to answer these questions. Open the sample, the malware number 4 in PE Studio, which library is blacklisted. Okay, let's do that. Come on, I'll go here, and I already loaded it in the PE Studio, I guess. Maybe let me go and exit PE Studio and do it again. PE Studio, malware number 4. Here it is, opening this. And now if I go and try to answer which library is blacklisted, I go to, I think it is still parsing the data, so that is why it is in the wait state. So we need to wait for a while. Yes, now it came, the libraries, and you can see the blacklisted library, just only one, RPC RT4.dll, RPC RT4.dll, and that's the answer. And what does this will do? And I think there is a definition, there is a description. Remote procedure call runtime. So let me copy this line and just put it here. I guess we will type it. Remote procedure call runtime. That's the answer. RPC call. Okay, moving on to the previous section. Signature based detection. So let me scroll down. I already got the outcome here. I go to the top. And what's the question? How many matches for anti-VM execution techniques were identified in this sample? Anti-VM execution. Let's see. What is the question? Anti-VM execution techniques were identified. Let's scroll down. Execute anti-VM instructions. 86 matches. So this should be the answer. Does the sample have the capability to suspend or resume thread? Capability, suspend or resume thread. Let's read through this. Get thread local storage value, TLS value they call. Create terminate process. Create thread, resume thread. 2 matches. So looks like yes. What MBC behavior is observed against MBC objective anti-static analysis? Scrolling up, anti-static analysis. So against it, disassembler evasion, argument obfuscation. And that's the answer. At what address is the function that has capability check HTTP status code? Are they asking address? At what address the function that has capability check HTTP status code? So they are talking about capability, right? Check HTTP status code, and looks like this one. Or at what address? So let me get the hint. Using PowerShell will help to cut. Come on. If I get the hint, what is the address of the function that has capability? Check HTTPS status code. Did I close? Did I close the session? I guess I did close it. I don't know what's the hint. I think if I answer this question, this ends. What address in the function that has capability check HTTP status code? Lost connection. Okay, I think I need to reset this. Hey, this is Perumal again from the future. Now, actually, we actually need to answer one more question. What is the address of the function that has the capability to check the HTTP status code? And here is the hint. So we actually used kappa already, but we did not use the verbosity. This time, when we use -v or -v, it is possible to grab more information. I guess that's gonna answer our question. How I managed to grab the results on PowerShell window. I think it is worth to showcase this. Here, if you see any method or any capability, under that there are plenty of details. So based on these details only, the kappa identified its capability. So I'm gonna go and search for the capability of check HTTP status code. So I will start searching this string status code, right? Yes, check HTTP status code. Yes, here is the capability, and I need to find the address. So this is the address, I guess. And let's see. Let's go and answer that question, and that's correct answer. So we successfully solved this challenge.